Okay, so I'm recording this a second time because the sound messed up on the first time. So basically this is just the intro notes to electricity. This is unit 10, where we're just talking about circuits and how they work and how electricity moves through circuits. Okay, so the main thing we need to know is what is a circuit, okay? And what a circuit is basically just a path that electrons flow, and how the electricity moves through basically a pathway. An open circuit is where it's actually a broken circuit. So if we kind of think about a circuit as a pathway, and I'll kind of draw one out here for you. Okay. Circuits always have like a switch, basically a little point where they can be opened up. So here I can see that if it's open, that actually my current can't keep flowing around in a nice continuous path. It gets broken up. Okay, so this is an open current. If I want a closed current, then basically all I would do is I would just close this door down here, and now it's closed. Okay, so in order for electricity to actually move through a circuit, you have to have a closed circuit. Okay, and you can see that if it was open, if this was broken here and I had this little doorway, then electricity wouldn't be able to go around. Okay, so this is what you saw in the simulation. You were looking at two different types of circuits. Basically, there's a series and a parallel circuit. So a series you just had one nice little path, basically like a box or a circle. Okay, one path that the electricity just kind of moves around. If you break that in any way, like if I have a switch, if I open my circuit, maybe I disconnect a bulb, okay, or if a bulb burns out, then I've broken that circuit, and now my electricity is going to stop right here. So that means all my other light bulbs are going to go out. Okay, all the light bulbs will, because my path has been broken. Okay. For a parallel circuit, you saw in your simulation where you can disconnect one of the bulbs, and as long as that switch does not happens like on an individual pathway, that switch or that disconnect, then all your other light bulbs are going to stay lit up, basically. Because you can kind of see, I still have this whole pathway that I could travel around as electricity. Okay, so the only pathway that's been broken up is this bottom path right here. Okay, so this is how Christmas lights work, right? This was in the simulation. I talked about how, so if you have a string of Christmas lights, right, or if you have them around your room or wherever you've seen before, where like one bulb might be out, but they still all work, okay? Or maybe there's just one little section that doesn't work, but the rest of them work, right? That's because it's a series. So you just have one little spot here that might be out, but the rest of them work the same way. This is how all the lights in your house are wired too. You can turn the lights off in one room. So I've opened the switch, I've disconnected this switch here in this room, but I can still have all the lights on in the other room because they're all on their own pathways. They're connected in series, they're in parallel, okay? So parts of a circuit, the power source is the battery, right? That's basic knowledge. A lot of these you're going to be familiar with. Conductor, that's just any material that can actually conduct that electricity. So in your simulation, you were using wire. Your house has wires running through it. Copper is a great example. Copper is very conductive. Okay, so usually it's copper wire. If we were in class, we actually would build a circuit where you could use a battery, a little light bulb, and you'd actually build it and light up your light bulb. And we use aluminum foil. So aluminum is a really good conductor of electricity, okay? So don't go stand out in a thunderstorm with lightning with an aluminum can on your head, because it will attract that electricity, okay? An insulator, it's just what it sounds like. It's going to insulate that current, okay? So electricity can't actually move through that material. Rubber is a really good example. That's why they say like your car is usually pretty safe in a storm, because the rubber tires help insulate that car. You can't move electricity through all that rubber. So it kind of helps ground the car. If you think about like your phone cord, right, your charging cable, it has like a rubber material along the outside, right? That protects you from touching it. It's not going to let any electricity escape that cord. That's why they say if you do tear that rubber, right, you just need to throw the cord away, because once you've exposed those wires on the inside, then electricity can start leaking out, and that's a good way that you could get shocked. A resistor, okay, a resistor does basically what it says. It resists the current. Okay, so it's different than an insulator. Electricity can still move through a resistor, but it just moves through very slow. Okay, so if I, let's draw a little light bulb here. Let's look at an example. Okay, so here's a little light bulb. And you know, inside the light bulb, you can actually see that little kind of curvy wire. Okay, this wire right here is actually the resistor. Okay, it's a different material than the wire that's running through your house. Okay, it's made of a different material, and it's not very conductive. It's a little bit conductive. It can still move through, right? Because we're not breaking that pathway, but we're just slowing that electricity down a little bit. And when that happens, remember in the last unit, we talked about how energy can be transformed. So if I have electrical energy that's coming in to my light bulb, okay, when it kind of gets into this little, it's kind of stuck right there. What happens is my electrical energy is transformed or changed into light. Since all that electricity can't make it through the wire, it has to get out somehow. That energy can't just disappear. It's not going to be destroyed, so it changes, basically. So it's going to turn into electrical energy, light energy, and also heat. That's why, so we get light and heat. That's why they say when you're changing a light bulb, you want to turn it off for a few minutes before you touch it, because you'll notice it's really hot. Because all that electrical energy is turning into heat and light. Okay. So these are just some other examples of resistors. Basically anything you plug in that gets hot or emits a light has a resistor in it. So like your hair dryer, it gets hot, right? When you plug it in, it actually has little coils in here that are going to release heat, because it's a resistor. Electricity can't move through very well. We talked about the light bulb already. If you've seen a stove like this, if you have this kind of stove, or even if you have like the flat top where it's flat all the way across, those are resistors up here in the top, right? That stove is actually plugged into the wall behind you. That's why it doesn't work when the power goes out. It's plugged into the wall, so it's taking electricity. It runs off electricity, and then once that electricity gets up here into these coils, it can't move through very well because these are resistors. So it releases heat, and then you'll also see a lot of times it turns bright red. That's that light that you're seeing. Okay, it's releasing light. The last two parts, we're familiar with a switch. That's just like the on-off switch, basically. A capacitor is probably a new term. That's what's on a camera flash. Basically, it's just a device that stores up a bunch of energy, and then it's going to release it all at one time. So it stores that electrical energy, right? And then at one time, since it releases so much energy at one time, it actually transforms to light. That's how we get a camera flash. You do have some symbols here. If the symbol isn't on here, then you don't have to know it. So like we don't have a symbol for an insulator or a capacitor. We're not going to talk about that. Okay, so let's real quick, I'm just going to do two examples of how to draw a circuit, because you have a circuit at the very end of your notes that I want you to draw on your notes. So let's say we have let's do a series first. Okay, series with one switch, one, let's see, one resistor, okay, and one battery. Actually, let's do two resistors. Let's make it interesting. Okay. So I know that my switch, I know I'm going to have a switch. So I need this one, a battery, a resistor, and then I know that I'm also going to have my wire in there somewhere. So I always start with my battery. So it's just kind of two lines like that, one smaller than the other, right? And then I'm going to put my switch right over here. So there's my switch. And you can put the little circles if you want to. I don't, but you can still see it's a switch because it has that little open door. Okay, and then I need 2 resistors. So what are my resistors? They're really our light bulbs, right? Like this could be a circuit with 2 light bulbs, but we don't actually draw a light bulb. We're gonna draw the symbol for a resistor. So there's my first one. I'm gonna do my other one over here, and then I wanna make sure that I complete my pathway. Okay, I don't wanna draw something like in a straight line. I wouldn't draw something like this. Okay, that is a big fat no. Let me get a big X. Okay, big no on that, right? That's not a complete pathway. Where's my current gonna go, right? It has to go in a circle. It has to be able to go all the way around and keep going. So I wanna make sure it's connected back as a square. Okay, now let's look at a parallel. Let's do the same thing. 1 switch, 2 resistors, and then 1 battery. Okay, so like I said, I always just do my batteries at the bottom. If I had 2, I'd put another one right next to it. So there's my batteries. Okay, I need a switch. So let's see, I'm gonna put it, it doesn't really matter where you put it, I'm gonna put it right there. Okay, and then remember, since this is parallel, I have to have these 2 pathways, right? It's not gonna be one box. It's almost like boxes stacked on top of each other. So I'm gonna put 1 resistor here, and I'll put the other resistor here. Okay, so now I have my 2 separate pathways that it could travel through. And it doesn't matter where you put the switch. You can put the switch anywhere. I just always put it there. And I always put the battery at the bottom, but you could put it anywhere. You could have the battery up here in the top and the other resistor at the bottom. You could move it around. It doesn't really matter. Like I said, just as long as you have the 2 pathways in your parallel circuit.